Let's go ahead and talk about some additional notation before we look at our next couple examples. The first thing we want to talk about is our factorial symbol. The factorial symbol looks like an exclamation point, and so you're going to see something like this written, n exclamation point, which you would read that as n factorial. Now let's talk about what that actually means. The n values that we're working with would be something that are greater than or equal to 0, and in this case would be an integer. So let's start by looking at 0 factorial. 0 factorial is defined as 1. Let's take a look at a couple, and let's go in order. So let's take a look at 1 factorial, 2 factorial, and 3 factorial, so that you can start to see the patterns. So I've written out the first three, and let's go ahead and take a look at 3 factorial. When I'm working with 3 factorial, that means I'm starting with my number 3, and I'm going to be performing multiplication, and I'm going to multiply it by each of the integers all the way down to a 1. So I would write this as 3 times 2 times 1, which in this case, when I multiply these numbers together, I'm going to get 6. If I was working with 2 factorial, I would start at 2, and keep on multiplying until I reach 1, which I did. So 2 times 1 is just 2. Obviously, 1 factorial in this case is just going to be equivalent to 1. Obviously, I could continue this pattern all the way down. Let's take a look at what happens when I'm working with n factorial. Obviously, I'm going to be starting at the number n, whatever that is, and multiplying it by each integer, one less than the previous one. So my first one's going to be an n value, and then n minus 1, and then n minus 2, etc., all the way down to this piece, 3 times 2 times 1. Here's what it would look like right now. Right, there's my n value that I'm starting with. My next number would be 1 less than whatever this number is. This one's going to be 1 less than this number, all the way down until I get to the 3 times 2 times 1. I could write this another way. I could also write this as n times n minus 1 factorial. This might come in handy if I had a fraction that I needed to reduce. Let's take a look at one more type of notation we're going to be using in this section. This is called summation notation. Let's pretend I wanted to find the sum of the first n terms of the sequence a sub n. And let me just go ahead and use a sub 1 plus a sub 2 plus all the way up to a sub n as my sequence for this example. We can use what's called summation notation, and that uses the symbol sigma to rewrite this sequence. This is our symbol for sigma, and now we have a couple pieces we need to go plug in. The sequence that I'm working with is going to be a sub k, and I need a start point and an end point. My k values here are going to start at a k value of 1. This is known as your index, or where your values are starting. Keep in mind, if I use a k value of 1 here, my first term would be a sub 1, and it is in my sequence. I also need to note where the end would be for this sequence. So I'm going to be continuing this pattern all the way up to a k value of n. So a sub n would be my last term, and it is. So your end point would be located on top of your sigma piece.